All right, welcome back to another calculus lecture video. In today's lecture, we are going to use the inverse function theorem to compute the derivatives of the inverse trig functions. So maybe we'll just go ahead and state a theorem, which I guess I'll just do in black. Theorem. So we have that the derivative of the inverse sine function, so we'll state this theorem and then we'll do one derivation. I'm going to write down the derivative of three functions, but we'll only actually compute one of these. So the derivative of the inverse sine function, that is the function where if I plug in x, if I plug in sine of x in place of x here, I just get x back out. The derivative of sine inverse of x is 1 divided by the square root of 1 minus x squared. And notice that if x is bigger than 1, then I'm taking the square root of a negative number here. So this course, or if x is equal to 1, then I'm taking the square root of a negative number, or a square root of 0, which is 0, and then trying to divide by it. Anyways, the point is that sine of x only has values between -1 and 1, and so its inverse function is only defined on -1 to 1. And so the only values of x which you would actually try and plug in here are, in fact, just values between 0 and 1. Okay, so the derivative of inverse sine of x is this guy. Let's go ahead and write down the derivative of secant inverse. So the derivative of secant inverse of x is similar. This pen is running out of ink. Very sad. This is 1 divided by the square root of the absolute value of x times the square root of x squared minus 1. Okay. And lastly, the derivative of the inverse tangent function. This is equal to 1 over 1 plus x squared. Okay, so we'll actually do this computation, but these other two we'll sort of take for granted, and I'll sort of wave my hands and say that the computation is roughly similar for these two. It happens to be the simplest in the case of tangent inverse, and so that's why we're going to do that computation. I'm only stating the inverse derivative, the derivative of the inverse of the three sort of non-co trig functions. We could have done cosine inverse, cosecant inverse, and cotangent inverse, but those are a little bit more squirrely to compute. So we're just going to confine ourselves with these guys and say that that's okay. Okay, so let's actually we'll actually show that this is the derivative of the inverse tangent function using the inverse function theorem. So let's go ahead and recall. So recall the inverse function theorem. States that the derivative of an inverse function, so f inverse of x, this is equal to 1 divided by the derivative of f evaluated at f inverse of x. And this is going to drive me crazy, so I'm going to cut the video and actually get a better pen with which to do the rest of this lecture. So when f of x is equal to tangent of x, the inverse function theorem is going to give the following. So the derivative of the inverse tangent function is equal to, well, f inverse of x is just tangent inverse of x, and then we need f prime of x, but we know that the derivative of tangent is secant squared of x. So this is going to give 1 divided by secant squared of tangent inverse of x. And now recall, secant squared is just 1 divided by cosine, so, or secant is 1 divided by cosine, and so what we really have is 1 over cosine squared of tangent inverse of x. And so this actually just reduces to cosine squared of tangent inverse of x. Okay? Now, how do we go about simplifying this expression? This is just a trig function composed with an inverse trig function. How do we exactly do this? And the way that we're going to interpret this is we're actually going to draw a square that sort of represents this inverse tangent function. Okay, so consider, and actually I'm going to do this on another page because our analysis is going to be somewhat lengthy. So we need to understand cosine squared of tangent inverse of x, whatever this quantity happens to be. So consider the following triangle. These are trig functions, so maybe it's helpful to draw a triangle. So we got, boom, just like that. And we're going to make this side length 1. This side is going to be length x. And then the hypotenuse, we know by Pythagorean's theorem, is going to be 1 plus x squared. And then we take the square root of that. So we square both of these, add them together, and then that tells us that the square of the hypotenuse is equal to that. And so to get the hypotenuse, we just take the square root here. Okay, and then I'm going to label this angle as theta. Now, what do we notice about this triangle? Well, note that tangent of theta, so if I were to compute the tangent of this angle right here, what would I get? Well, I would get the opposite side divided by the adjacent side. So if you remember the little ditty they teach you about how to remember tangent, sine, and cosine, this is the TOA, so opposite divided by adjacent. So this is equal to x. X divided by 1 is just x, right? And so tangent inverse of x, if I just apply the inverse tangent function to each side of this expression, I just get that tangent inverse of x is equal to theta. Okay, well, I've replaced this symbol with this set of symbols with this one, but how does that help me? Well, this tells me that I can interpret this geometrically. So really what I need to know is actually the cosine of theta. So thus, we need to know cosine of tangent inverse of x is just cosine of theta. So we need to know cosine of theta. Well, I have a triangle. I can compute that in the exact same way I just computed tangent of theta of x, or tangent of theta. So cosine of theta, so we have cosine of theta is equal to, well, cosine gives you adjacent over hypotenuse. So this is 1 divided by the square root of 1 plus x squared, adjacent over hypotenuse. And now notice, what is cosine squared of tangent inverse of x? This is just cosine of theta quantity squared. So, and since cosine squared of tangent inverse of x is just cosine of theta squared, we find that, well, what was cosine squared of tangent inverse of x? This was precisely the derivative of the inverse tangent function. So the derivative of tangent inverse of x is equal to the square of this thing, so cosine of theta squared, so 1 over x squared. 1 over 1 plus x squared, my apologies. And we're done. Box. That's how you indicate the end of a proof in mathematics. But this is how we can use the inverse function theorem to compute the derivatives of these things, and something similar happens for the other two inverse trig functions. Okay, so there's not really a ton to do here. We'll use the derivatives of the inverse tangent functions in examples of derivatives, but we won't do a ton of different sort of things with the inverse tangent functions. Okay, so I will see you all in the next video.